Hey everyone, it's time to step into the lab section for hands-on experience with Azure Load Balancer. Azure Load Balancer is a critical component in distributing traffic across multiple virtual machines to ensure high availability and fault tolerance. First, ensure you have a valid Azure subscription and access to the Azure portal. Once you log into the Azure portal, you can go for the Azure services, and from Azure services, you can choose the load balancers. Under the load balancer section, let's stick to this option which is called load balancer, and from here you can create a load balancer, so you can use this option or you can create it from here. The moment you are going to create it, it is going to ask for the valid subscription and the resource group. So I'm going to use the same resource group where I have already deployed my virtual machine, and I want to name it LB Lab. Region is going to be the East US. Now, look at these values, the SQ type. As I mentioned earlier, throughout this session, I'm going to use the standard load balancer. The basic load balancer, you are going to have some security challenges, and that is only meant for the lab purpose. When you get into the production, you are going to use this standard SQ. For difference between the basic and standard, you can refer to Azure Microsoft documentation, where there are going to be some differences in for this SQ capabilities. It can be number of instance which you can accommodate within the pool. It can be the security. So Zero Trust comes in built with a standard SQ. So there are other many differences which you can refer to the official documentation basically. But in this lab, we are going to use the standard SQ. Top of that is going to be a type. So as I mentioned, a load balancer can be public, it can be internal, and I'm going to show you the difference, how it will look like. The moment you are going to say it's going to be public, that means you are going to assign a public IP address to the load balancer. If it is a standard, your front end will come from the same VNet subnet where you're going to deploy it. Top of that, the tier can be regional and it can be global also. Regional means the basic functionality what we have seen, whether you can go for the public and internal, those can be regional. And if you go for the cross region, that is going to be the global load balancer. So let's just start with public. And the moment you choose the public, these options are available. If you go for the internal, that is only going to be the regional component. So let's see what are the option comes. So first, if I go for the public and the option tier is going to be the regional, go to the next front-end IP configuration. And this time front-end IP address is going to be the public IP address which you need to assign. And when you assign the public IP address, it can be your IPv4, it can be IPv6, or you can use the IP prefix as well. So let's use, or maybe let's explore all the options, then we come back and complete this task. After assigning that, what will happen? You need to configure a backend pool. At least one front end is needed here. Okay. I'm going to use IPv4. This is going to be the public IP address. So let me create a new one. Pip LB. I will make it 1. And I will tell you the reason for making this availability soon. Now let's add it. Let's go to the next option, which is going to be the backend pool. And in the backend pool, basically, as I mentioned, when you are going to talk about distributing the load, it means you're going to have multiple resources to meet your fault tolerance and the high availability. So you need to create a pool where you're going to have the number of instances allocated to the pool. Let's just name it as a pool. Then you need to choose a virtual network, and my virtual network is going to be this one. I will use IP address, and the first IP address is going to be dot 4. This is basically, let's configure it. We can change it later on as well. I do not recall what was the private IP which is allocated to the machine. So I will just leave it to the 6 just to show you the demo. And then we are going to save it. Similarly, you're going to have more options, number of instances. You can basically choose from those IP addresses from here. Let's save it and go to the inbound rule. And inbound rule, basically how you want to distribute your traffic. I will put rule 1, front-end IP address, and this PIP to be created. This is going to be the pool. Or we can do one thing, let's add all these options later on. So I'm going to hit review and create. I'm going to pause my lab, and once this is done, I'll be back. My deployment is completed, and we can explore the resources. So this is showing the front-end IP configuration, and the front-end IP where we can see is from 172, 190, 124, 135, and that is going to be the public IP allocated by you from Microsoft range. We created a backend pool, and this pool was named as pool, and you're going to have this client IP address, which is going to be private in the nature. My machine is not started yet, hence it is showing you the T allocated. Then you have an option to do the health probe. The health probe means whatever the application, whether it's going to be a web application or any other, you can put some sort of the probes from the load balancer, which is going to track whether that application is working as expected or not. And in case that application fails, this virtual machine is going to be out of pool. Then you can create your inbound NAT rule and outbound NAT rule as well. And in the overview section, basically, we see what is going to be the location, your subscription ID, and many other things. This also works for IPv6, and you can refer to one of the lab which I've done where there was a IPv6 outbound traffic which was handled by your load balancer. So now I'm going to create multiple virtual machines and we'll add that to the pool before we perform the lab. Now I'm going to create two virtual machines, and those are going to be the part of the pool we created. These are going to be the newly deployed machines. So the settings I'm going to choose, I just wanted to show you the availability zone option, what we have chosen, what it mean, and how it is going to correlate with your load balancer options. So this is going to be my subscription, my resource group, and I'm going to name this machine as a VM1 LB. The second machine will be named as VM2 LB. The reason is going to be the East US. Availability zone is the option which I wanted to focus on. So I'm going to choose a option 1. And the reason behind, while assigning the IP address, we have assigned the IP address which was also associated with the zone 1. So my machines and the load balancer IP resides within the same zone. If this zone is going to fail, it means my load balancer and the application is going to fail. But we are going also see the options available to make it high availability. But let's start with that. So this security type is going to be the standard. Image is going to be the Ubuntu, and I'm going to put my passwords. CPU size, that's going to be the standard one. Here you need to allow the inbound port. So by default, it is going to be 22. And then top of that, I'm going to add port 80 and 443. And the reason behind I'm going to run the Apache on top of this Ubuntu server. So I'm going to create two machines, and once those are provisioned, we'll resume this session. Both the machines I created, they are up and running. So I can see VM1 and VM2. These were the two machines. and they have the public IP address allocated to them so that we can directly log in from the SSH and install Apache. And in between, let's take a look on the IP addresses got assigned to them. When you click on the VM1, the private IP address, which is going to be the part of the pool, is going to be 5. And then you have, it should be .6. No, it's .8. So you have 5 and 8. So let's modify the pool. And for that, you need to go back to the LB, click on the LB, my pool. And from here, basically what you can do, you can edit it. So 5 and 8, they are going to be the IP address, which are going to be the part of the pool. And now let's try to save it. And we can also see the resource name is reflecting here. That shows we have chosen the right resources. Once you save it, these settings get updated. And now it's time to run the application which we talked about. There are various ways you can run the application, but I'm going to install here the Apache server on both the servers. I have already installed Apache 2 on these two Ubuntu machines what we have, and apt install Apache 2 is going to be the command which you need to run on these machines. Top of that, I have also changed the text file or text inside this index.html just to identify when you hit port 443 or 80 on the public IP address, so at least you can identify based on the text which pops up on the default page. Now, these both machines are running. Let's directly test the connectivity and see whether these are responding directly without load balancer. To test the connectivity, basically, I'm going to hit directly on this public IP address, which is assigned to VM1. For that, I'm going to open a new tab. And in the tab, I'm going to type the IP address. And now we can see this is machine is going to be VM1. Similarly, I will go back and test another machine. And this time I'm going to replace this IP address. This is my second machine. It means both the machines are responding. Now we need to put these machines behind the load balancer. It's time to configure load balancing rules. So let's go to the load balancer, navigate to load balancing rules. And here you can add a rule. So I'm going to add my first rule, which is going to be the rule 1 LB. This is going to be the V4. My front end is going to be the public IP address assigned to LB. My backend pool is going to be the existing pool. Protocol is going to be the TCP. Port, this is going to be the port where front end is going to listen on. So you have option, you can go for port 80 and 443 since I am running two services. So let's test these on port 80. My backend port is going to be 80, and let's go for the TCP. This is health probe, you cannot leave it blank. However, I'm going to discuss these health probes in details. Session persistence, I'm going to leave it at a none. The idle timeout in minute, this can be between 4 to 100. And this is a kind of the timeout value. And once this is crossed, your load balancer is not going to maintain your TCP or SATP session. Or I can reduce it to the 1. The value must be between 4. So let's keep it 4. And we will save it now. Once this is done, we are going to test while hitting the public IP address which is configured on the load balancer. Let's now test our connection while accessing from the public IP which is assigned to the load balancer, which is going to be 135. And now we see we are landing to the first VM. If I keep refreshing it, let's see what happens. Now we can see it got changed. This tells you the load balancer is working as expected. There are a couple of more testing what you can do. Since we have seen while refreshing, sometimes it goes to the VM1, sometimes it goes to the VM2. You can configure your session persistence. Once you configure that based on the tuple 2 or tuple 3 parameters, you can ensure you are landing to the right resource on the backend pool. So let's see that option. Now let's take a look on session affinity and session persistence option. So you go to the load balancer again, go to the load balancing rules. This was the rule which we created. And now we can see there's an option what we have chosen as of now is none. Though you have an option client IP and client IP in the protocol. If you read the description, it tells you the session affinity or persistence specifies that the traffic from the client should be handled by the same virtual machine in the backend pool for the duration of the session. None specifies that the successive requests from the same client may be handled by any virtual machine. So if you're doing a classful application, then you have to configure the affinity. Client IP specifies the successive requests from the same client address will be handled by the same virtual machines. So now let's try this time to make it client IP, and we try to refresh it from the browser. Now when I try to browse the public IP address basically which is configured on the load balancer, this was landing to second VM. So if I refresh it and keep refreshing it, it should not go to the VM1. And it's not going. That is the expected behavior of the affinity and the persistence. Thank you for watching, and I will see you in the next section.